Hello and welcome everybody to our FreeScan webinar today. I'm gonna first of all show you shortly the benefits of the FreeScan, what we did so far with the FreeScan, and also we have a limited offer for the FreeScan right now together with the Verisurf software, which you will see later on as well in a short demonstration, the functions of Verisurf and what you can do with the scanning data to do the inspection. So, what did we do the past years with our FreeScan? We did a lot, to be honest. So we increased the stability of the scanner, we have a new UI design, we increased the performance, and we have the wireless model for it. Stability, first of all, there is a lot we changed so far within the FreeScan. And one of the biggest thing is for sure the structure of the scanner, that we have a new carbon fiber inside, we have a system optimization for it, and also new hardware itself. That's what we changed as well in the past. We also have a new UI design for our software. As you can see, it's pretty the same like our Einscan software, the EX-Scan software for the 2X and 2X Plus. It looks more professional and it has our unique appearance of the shining 3D design for sure. Also, we have a simple workflow right now. In the upper part, over here you can see the workflow part of the software, but we will later on go deeper into it. We have a simplified calibration. It's way faster and way easier to get the data, just one calibration, which takes about 30 seconds to do. We have a simple parameter setup for the scanner, so the adjustment is automatic. The laser is adjusting automatically to the color of the object. And we have a new switch mode to the single line, which all the FreeScans have. So you can go from the multi-line to a single line to scan deeper into holes. The performance as well, as you can see over here, the version 2.5 was our old version, and the version 3 is the newest version we have. The benefit of the new software update as well, the higher accuracy we can achieve with it. As you can see over here, we scanned this artifact and we scanned it 6 times, and the results are really good, to be honest. If we talk about Metrology 3D scanners, we always need to talk about the repeatability as well. So we scanned this bigger part itself several times and put them together and did the inspection with this part. You can see the repeatability is pretty good as well. It's between 0.001 millimeter up to 0.02. The accuracy of the scanner, as you know, is around about 0.03 millimeters, so 30 microns of the FreeScan. Also, it's way more efficient to scan with our FreeScan right now. Before, we had a lot of steps to go to scan a really big object, a really tall object, and right now those are really less clicks. You will see that later during the demonstration. Also, the scan speed itself, if you compare those two parts, you can also see on the right side the specifications of the computer we used. We increased the speed up to 40%. Also, the meshing speed we increased a lot, again up to 40%. The data quality we increased a lot in the past years, especially for the new update. Here are some examples. Also, it's way easier right now to scan outside with the FreeScan and to scan really dark and reflective objects. We have also the option right now to use the smaller markers to capture, let's say, on the right side, this statue over there. New functional software as well as the merging function, so we can merge based on the manual alignment mode. That means we choose more common points for both files and they will be merged together, or we have an automatic function as well, which works, or we can work with the markers. I want to talk shortly about the wireless solution as well. For all FreeScans, if you buy them right now, you can always upgrade them to a wireless solution. That's pretty nice. So if you need it in the future, don't worry, you can always upgrade it. And it's additional for any FreeScan you will buy right now. Here are the specs again of the Airmaster. That's the wireless module we will get. The working hours around 3 hours, and the standby mode is about 12 hours for this battery pack. I just shortly want to go into small tips and tricks before we start with the demonstrations. So first of all, we need to think what we will do. Basically, we have 2-3 kind of main applications for the FreeScan. I just want to mention pretty shortly. So the first option is reverse engineering. So we have an object, we 3D scan it, and we get this STL file over here. So what we can do right now, we can do the surface reconstruction. So as you can see over here, we can go from this STL file we have over here to this step or ICHOS file. That is one thing we can do with the scanner. Another thing is inspection. So we scan in larger objects, have the STL data over here, overlay it with the step data and get this color map and measure it. That's what we did a lot in the past few sessions before. Another thing is design. So you scan something and you probably round it more to make a ring, for example. But to be honest, for the FreeScan, it's not really such a huge application. Really important if we talk about metrology scanners, we need to talk about the positioning. So we have most of the time 3 kind of positioning modes. The first one is feature positioning and texture, and the second one is markers positioning. So feature positioning means the scanner will align the data we will capture based on the features of the object itself. So you can already think, if we align something based on the features, the software needs to guess as well if it's right, if it's really correct to align it over there, and we have an alignment error afterwards. That's fixed. The alignment error is different on the part you will scan. So if you have a part with a lot of features, for sure the accuracy will be better afterwards because the software can guess and the scanner can guess on more features. But if you have an object with less features, it's really hard for the software and for the scanner to align it with a really good accuracy afterwards. So if you scan, for example, a table and we don't have any texture on it, any features on it, we will need to use markers for that. And the thing about markers is that the software and the scanner can really tell where he is and how he should stick the pictures together, because we know the markers are fixed in a position. So that will increase the accuracy, and also it will help us to align if you have a flat surface without any features. So keep that always in mind. Most of the, as you already probably know, if you want to scan with a really high accuracy, even for the iron scan, you will need to use the markers for that. Also, really important, resolution itself. So if you talk about resolution, I know most of you, they want to see the highest resolution possible because they want to have the most beautiful results the scanner can get. But if we talk about resolution in comparison with inspection, does it really make sense to take the highest resolution over here? If we look at this example over here, let's assume we want to inspect this plane over here to the other side of the plane over here. So the distance. If you will see right now the triangulation of this part compared to this part, it doesn't really matter because a plane surface is a plane surface. It doesn't matter how many points I captured. I can create a plane based on the 4 points. 1 point here, 1 point here, 1 point here, and 1 point here. The same for here. So that would be the same accuracy if I use high or low resolution. If I want to display this round part over here, it doesn't matter what kind of resolution I will have, because it will be the same result. The resolution is not connected to the accuracy in this kind of way. For sure, if you want to measure the edge over here, how sharp it is, and if you want to measure it, for example, if you scan it with a really high resolution, you can see it down here, we will get kind of like this result over here. If we scan it with really low resolution and we will make an outline out of that, it will look like this over here. For sure, in this case, the resolution can matter. But if we do basic inspection or the inspection itself, please keep in mind the highest resolution doesn't mean the best result. Also, the problem with high resolution is you will get a huge file afterwards, and that's probably difficult to post-process. Here again an example, if you want to display for sure the letters and inspect them. Normally I never had an example where you need to inspect the letters itself on a product. Most of the time they're even not on the step data itself, but if you would need to, for sure you should go for the higher resolution. I just want to give you the idea. Here we have the high resolution of the left part, it's 220 megabytes, and the low resolution is 18 megabytes. And as you can see, the file itself doesn't change at all. Like, we have all the details, all the holes, and they're the same. So the accuracy here, it doesn't really change, just the resolution itself on the object, for example, those small details I want to see. But with this 18.7 megabyte file, I can do way faster my inspection process compared to the 220 megabytes on the left side. So to give you like a short general rule about resolution, and we can talk about coins and smaller objects, the resolution should be higher than 0.2 millimeters. For engine parts, you can go between 0.3 to 0.4 millimeters. It always depends how many details you need and how, like, the smallest hole for sure you have on these objects. Furniture can be from 0.5 to 1.5 millimeters. A human body 1 millimeter to 1.5 millimeter, and a full car for 2 millimeters. Otherwise, the file size will be too big to post-process afterwards. So, hello everybody to our FreeScan webinar today. I have here our FreeScan X5, and first of all I want to show you what you will get if you buy our FreeScan X5. So the first thing I can show you is our calibration certification. You will always get that if you buy the scanner itself, so that's really important for your calibration process. You will get for sure 5,000 markers. Those are 6mm markers. We also have smaller ones if you will need it. For sure you will get a power cord with your power cord for your country. You will get a cable for the scanner itself, and a second cable. If there is any problem with the first one or you will lose it, you can always use the second one. For sure you will get the scanner itself. The scanner is pretty easily explained. Here you will plug in the cables. You have 4 buttons over here. One is to start and stop the scan, minus and plus, and the last button over here is the mode button, which you can go into the different scanning mode or pair adjustment modes. Over here we have our LED light, which indicates the distance of the scanner. That's the scanner itself. Then you will get a dongle. You will need to plug it into your computer to use the scanner itself. And under this stuff over here, you will get the calibration board. That's it. All those things are included in our FreeScan X5. So let's jump into the calibration. So when we are ready with the calibration, we just open up the calibration board over here. We will put it down. I will move the part, and we will start with our first position, and we just move it slowly up. We will go on the right side over here on the calibration board, and we just move it slowly up until we have all the positions. The same we will do for our left side. There we go, from this part over here, and one more time from the front. Oh, I missed one part. So that's it. Now the calibration is done, and we just need to wait until the software will say it's successful. As you can see here, the result succeeded, and we are ready to scan. So I will go into my first scanning session. We will get this screen for the beginning. So I can choose between a new object. I want to create a new project itself. I want to reopen an old project. I want to merge 2 projects together. So what we will do right now, we will create a new project. I can choose the resolution over here from 2 millimeters up to 0.05 millimeters. Just keep in mind the resolution you will choose, the same the scanning speed will depend on. So if you choose a really high resolution, it will take a little bit longer to calculate and to scan the part. And if you choose a lower resolution, for sure it will be faster and it will also be faster to capture the part itself. So let's say we want to go for the 0.5 resolution. I want to save it here on my desktop, FreeScan test, and we will call it project. And now we can choose between 3 different kind of modes. The first mode we have is the cloud scan mode. That means we can directly scan on the object. So we will start to scan directly. Frame scan is we will only capture the markers first of all. And import frame is we will import the frame first of all and then scan the part itself. We will go deeper into those functions later on. Right now I just want to show you the cloud scan data. Okay, let's go to our first object we have here, the rim. And the first thing we always do with the 3D scanner is we will adjust the brightness. So I click the M button, I will get into the color adjustment control, and I just press this start scan button, and now the scanner will automatically be adjusted to the color of the object. If everything is green in our cameras, we will just press OK, here the button again, and then I will press start scan. And as you can see, it's pretty fast. We can already start scanning the object over here, just go around a little bit. We can go here inside a little bit more to scan this part over here. All the sides, we want to get all the details we can get. Also really important over here, we have an LED light over here. If this LED light is green, we have the perfect distance. If it's too far away, it's red. If it's too close, it's blue over here. So the perfect distance is green, and you can see it as well in our software itself. So let's just finish our scan over here. So we have a closed model afterwards that we can reuse probably for inspection or the reverse engineering part. There we go. If I want to go down here, I just jump here on the edge a little bit. So I need to capture a little bit of the part over here down here. So I need to turn a little bit and get the most details over here. Ooh. Now I made it to the side over here, and I can just like roll my part until I captured everything. Here it's a little bit different, so I can adjust the brightness again. I just stop my scan for a second because it's more reflective on this side. I can go on the mode again and adjust my laser. Now everything is green. That looks a little better. Let's go back and let's start scanning. So it's easier for me to capture everything. It's pretty easy, as I said, to scan the part. There's not a lot of work I need to do. Just go roughly over the object over here, and then we finished our scan. We will try to get everything over here, so we have the finished result afterwards, but that looks pretty good. I can also increase my shutter over here if I'm not good enough right now, and then I'm almost finished. Okay, so I'm done with my first scan. I can check it out over here. That looks pretty good. So I want to delete out all the noise I have over here. Pretty easy. I go on the object. I go on please delete me everything which is not connected to the main object. So now the software will recalculate everything, and you can see over here the whole rim is red. I go on invert, and now all the noise is red. I go on delete, and it's done. The next step is I will finish this scan and optimize the cloud. That means the software will recalculate the point cloud itself, and afterwards we can mesh it to an STL file. That takes a little bit. Almost ready. A little bit is still to go. I think the pretty good stuff over here is that you don't need to use any marker, any spray for shiny reflective objects. So we have our result here. Let's say we are satisfied. We go on mesh data. We can adjust the parameters if we want. We also have a preview mode, so we can activate it. And if we go on the object, we can first of all check a small area, how it will look like. If we can zoom in, I can show you. Here it's meshed right now, it looks okay. And then we can start our mesh. After we finish the mesh, we just export it as an STL file, and then we can do our inspection and all the other stuff with it. It's almost ready. Just a little bit. Okay. %. Okay. So we can already see 95%, and the file should be ready. There we go. We can check out the result over here. So when we are done with the scan, we can just create a new project and scan our second part. Okay, let's start with our next scan. It's this part over here. Mold injected part we have here, and we want to do later on as well the inspection in Verisurf with this part. So as I told you before, we will first of all start to capture all the markers, and then we will jump into the normal scanning process. So I just press start again. And now I can capture all the markers first of all. It's as well easier to capture the markers, all markers, because the scanner doesn't need to see everything, only the markers itself. So he doesn't need to take care of the laser lines and anything, and that's faster. Also, another benefit of this scanning part is if we capture the markers before, we can scan bigger objects and just, for example, measure from one distance to the other distance and just stick a small line over here, and we don't need to scan the whole table itself. Okay, we are done with it, so we can see the markers over here. Looks pretty good. And the next step, we finish the first scan and optimize the frame. There we go. And now I can just take the part, press start scan, and scan the part. As you know, we choose the higher resolution right now. So we will see pretty good details afterwards. For this part we have a lot of different angles, so I need to go on it a little bit to capture everything. But it's no problem to hold it in my hands, the part itself, and scan around it. There we go. And the benefit, because I didn't scan I captured the markers before, I cannot lose tracking really, because the scanner already has all the markers, all the information, and that's a huge benefit of it. So almost finished over here. So now I can just turn my object, and I will scan it on the other side. Pretty fast, pretty easy. If you want, you can also download the STL file afterwards and check out the result. Okay. From this side a little bit more. We want to try to capture most of the part. A lot of people always ask me if they should go for the highest resolution possible. I say for sure you can go for the highest resolution possible, but your file afterwards will also be way higher compared to what you probably need for it. If we take this example here, there are not such small details that you will need the highest resolution for it. And if we do the inspection itself, it doesn't matter if you go for 0.3 millimeters or 0.5 millimeters. Because you will keep the same accuracy, just the details itself will be better afterwards. What you need to keep in mind for sure if you want to measure the edge, for example, the sharpness of the edge, you should probably go for the highest resolution possible. Looks pretty decent right now. I think we can be satisfied with our objects. We can do one more thing I want to show you. We can stop the scan for a second and we can activate a single line. So we just wait until the view is ready for rescanning again. We press long on minus and now we will get a single line. And if we go to the objects, we can see the single line is scanning right now. And the huge benefit of that is that you can scan deeper into holes, for example. And we can capture everything over here, and that's the huge benefit of it. Okay, finish again, and that's it. The next step, we want to clean up our scan again a little bit more. That's what we can do pretty easily as well. We will go on our object itself. 1 second, I need to activate it. I can choose my data over here. Okay, go on the region over here. I need to activate the points for sure. Go on invert. No, not the markers, sorry. Don't choose the markers over here. Okay, we go on invert, and now we will delete it out. Okay, when we finish with that, we finish and optimize our frame, and the next step, we will mesh this into an STL file. Almost finished. There we go. Our file, you can see really nice, the letters over here, pretty well written. I can always activate my markers and check the result itself. Looks pretty good. And now I can just mesh it to my STL file. Okay, so for our last scan, I want to scan this part over here without markers on it. So I will just put it on display over here, the manual turntable. I stick some markers around it. I use those 3D printed helpers to get also a different angle the markers itself. That will also increase the accuracy afterwards, if that would be important for this part. But it's not really for this one over here. Let's go on it. We go on apply, we go on a cloud scan. We first of all adjust the laser to the part itself. It should be green again. Looks pretty good, I would say. A little bit higher. Yes, that looks good. Exit. I'm still in the single mode, so I will just change it for a second into the multi, into the cross line. I will go on the object, and there we go. Let's say I need to increase the brightness of the laser a little bit more. I can also do it here during scanning. So I will capture something of the table here. That's not a big deal afterwards. I will show you why. I can press stop. And now, because I capture those markers, I can create, I will activate the markers mode. I will create a pretty nice plane over here, which will delete out automatically the turntable itself. And even if I go back on scanning, the scanner wouldn't capture under something under this plane that I created over here. Let's say we are fine. We can just see if there is still some missing around it. Let's go back from the markers mode, go on the object, and we say, please delete everything which is not connected to the main object. We go on invert, we have it, we delete it, and now we'll mesh everything to our STL file. It's going on here right now. Almost finished. So we have our perfect point cloud over here, and now I will go now my mesh and start my mesh, and then we can check out the end result of our STL file. It will take a short second. Okay, almost done. The point distance right now, as you remember, was 0.3 millimeters. We could also go higher to get even more details for this part. But that's it. And you can see all the nice small details we captured with our FreeScan X5. So, that's it for this part. We will jump now into this inspection process. And if you have any questions afterwards, stay in line and we'll answer them afterwards in our Q&A session. Thank you very much. Have a good day and talk to you in some seconds.
Verisurf software helps manufacturers improve quality and increase efficiency while saving time and money. Verisurf works closely with customers to automate first article and production inspection, scanning and reverse engineering, tool building, and assembly guidance processes. The software lets users interact with parts both physically and digitally in real time, capturing measurement data, comparing features to nominal GD&T specifications, generating reports, and creating intelligent geometry.
One of the things that makes our software unique is our commitment to model-based definition, commonly referred to as MBD. With MBD, the CAD model is the nominal definition to which all parts are measured and inspected against. All the manufacturing tolerance information is included in the CAD model. This maintains digital consistency from design to manufacturing to inspection and quality reporting. We pioneered MBD for model-based inspection, displaying real-time deviation on the PC platform, and it remains the core of our software today.
Verisurf software is built on a CAD platform with true intelligent 3D modeling, open platform architecture, and Verisurf device interface, making it compatible with virtually all CAD software and measurement hardware.
For this demonstration, we'll be looking at offline scanning inspection, and the data we'll be using is from the Shining 3D FreeScan system. So let's go ahead and import the data. Okay, let's turn the CAD off for a second. Okay, so there's the data. It looks very good from the FreeScan system. So let's talk briefly about some of the mesh editing tools we have within Verisurf. So if we right mouse under the speed menu, we have edit mesh. So different types of selection: area select, single select, round disk, window select. We can grow the selection, we can shrink the selection, maybe take it away from edges when we want to fit features. Then the interaction, what we want to do and how we want to work with the selection. We can smooth, sharpen, refine, filter. We can delete it, we can copy it, we can cut it. We also have fit features, so we can force the software to fit a specific type of feature to the selection. We have all the different geometric features there. Other tools we have, we right mouse click tools. Again, we've got the smooth, refine, offset the mesh, filter it, global register, and register to nominal. These are for the alignment, and we'll look at these a little bit later. Another tool we have is power mesh. So power mesh is a great one-click operation for cleaning up, refining, smoothing, and giving back a watertight, uniform mesh. Let's bring the CAD back into play. Okay, so for this exercise we need two inspection plans. One to do the alignment and one to do the inspection. So if we go to the Automate tab, just make sure the mesh is selected. Create a plan. Let's call it alignment. So we give it a command, double click. We're going to tell it to do a global register. The selection is the mesh. So the global register, this will take the mesh and get it very close to the CAD model. So now we need to give it another command to tell it to do a fit to the CAD. So register to nominal, this will fit the scan to the CAD. Set selection, choose the scan. Okay. So this is now, in its essence, the alignment program is done. So now let's turn off the mesh for now. Go back to Automate, get a nice top view. And let's create a plan to do the extraction. We'll look at extracting maybe this circle, and the sphere. So we go Plan, create a new plan, called Extraction. Okay, there's various ways where we can import and add CAD features to a plan. We can right mouse click, add from CAD, and we can force it for a particular feature. Or we can choose this icon, add feature from CAD. So the software will determine what type of feature it is. So let's use this one. So I'll click this circle, this one, and the sphere. Then press the Enter key. Okay, so there we have the nominal features in the plan. So now we're going to decide what we want to see in the report in the balloons. So I'll select the two same feature types. I don't want to look at the X, Y, Z. I just want the diameter, I don't want the position. We can change the tolerance in here as well. And the sphere. We'll just get the diameter for the sphere as well. Again, we can change the tolerance. So let's set out the balloons so we can get a nice view. So if we click the move, we can drag them around. Let's zoom the CAD a bit, drag this one back, zoom up a bit. Let's turn off the colour bar. Okay, got those there, this one here. Okay, so now we can get a screenshot of this for the report. So we've got a screenshot, click in the white space, press enter, and there's the screenshot in the report. Okay, so now we're ready to do the inspection. So we clear all, change to alignment, and then we run. Okay, that's the alignment complete. Now we'll change to the extraction and we'll run offline. Let's hide the mesh and run. So there's the measured features automatically extracted from the scan data. Let's do a surface map, a colour map of the surface, how good it is to nominal. Let's hide these. We go Analysis, Analyze. And now we have a colour map. We can put the legend up the side. If we want to change the tolerance, we double click. Choose the tolerance. Let's set the view for this. Let's now look at taking a section cut right across here. Let's hide this, turn back on the mesh, go into reverse, slice mesh. So we're going to slice it along the X, which is this direction, across the length of it. And we can choose where to slice by dragging the slider bar, or we can type in a value. So I'm going to slice it on the 0. We're going to save clouds. I'm going to set a minimum distance of 1 millimeter. So we save as a cloud, slice, turn off the mesh, and there's the slice there. So let's join these into one, merge them into one point cloud. Let's hide the mesh and look at a right view of this. So there's the slice and there's the point cloud. Okay, let's turn the CAD back on. So let's now do a colour map. So we select Analysis, select the point cloud and go Analyze. So now we can turn off the CAD, go into the slice, turn on the points, there we go. We can add things like balloons on these, so we can display various things. We'll just display the 3D deviation for now, just on some discrete points. Okay, and we'll save that as a view. Okay, so now in the report, if we want to add a screenshot, of this, and then we want another screenshot of this, and then we can hit the report. So that was a quick run through of the inspection with scan data. Very quick, very easy to align, very fast to do the extraction, slicing, mesh editing. This is another great example of sheet metal part, how quick it is to bring data, scan data into Verisurf and to align it very quickly and to automatically extract the features on the part. So let's go ahead and import our data. Take the point cloud. Okay, so there's the CAD model with the holes, the nominal positions, and this is the scan data. So to do this task, we need two plans. We need one for the alignment and one for the extraction. Okay. So the alignment, we have a global register. So first of all, the software will take the point cloud. It will get it very close to the CAD nominal. Then we'll perform a register to nominal, which is a surface fit. And then we'll switch to the extraction plan and automatically extract these nominal positions of these circles. Let's go across, change to the alignment. We'll run it. And now we can look at the automatic feature extraction plan. So we choose the plan, run offline. You can see it's very quick and very easy to do this with Verisurf. If you want to report, click on Show Report. You get the text and a screenshot. Okay, so this was another example of how quick and easy it is to import data, scan data into Verisurf, whether it's a point cloud or a mesh, and run a plan to do the alignment and to do the automatic feature extraction. In this example, we have a typical sheet metal automotive part that was measured with a hand scanner. So if I fit the screen, we can see the two are not aligned, they're in space. So we need to align the cloud to the surface, then we need to align to these datum positions indicated here. Okay, so to do this we need two plans. So the first plan is the alignment. So we'll do a global register, so the software will get the cloud very close to the surface. Then it will do a register to nominal, and then it will run an autoline alignment to fit to these target positions here. Once we've done that, we run the second plan to do the extraction automatically of these holes represented by the CAD circles and do a surface color map. So let's go to the alignment and let's run the plan. The alignment's done. It's done to the datums as well. We accept. Now we can change the plan to the extraction plan. We run offline. And there's the result. We can show report. Very quick, very easy. So this is an example of a typical sheet metal part. Very quick to do the alignment with offline data, to inspect hole positions, create surface color maps.